Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 2 in the JWT attacks module titled JWT Authentication Bypass via Flawed Signature Verification. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content, select all labs, do a search on the JWT module and select lab number 2 titled JWT Authentication Bypass via Flawed Signature Verification. Alright, let's get started. This lab uses a JWT-based mechanism for handling sessions. The server is insecurely configured to accept unsigned JWTs. To solve the lab, modify your session token to gain access to the admin panel at /admin, then delete the user Carlos. You can log into your own account using the following credentials, and we're giving credentials of a regular user account. Alright, so the goal over here is to modify the session token to gain access to the admin panel and then delete the Carlos user. Let's access the lab. Now, notice over here, I am using the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Just like we did with the previous lab, you do need the JWT editor extension, and so if you do not have it downloaded, you could download it from the extensions tab by clicking on BAP Store and then installing the JWT editor extension. Alright, the first thing we're going to do is go to my account and log in with our regular user. Hit login. Now notice over here that requests get highlighted in green because they have JSON web tokens inside of them. So if we make this a little bit bigger, you can see over here when you log in by providing your username and your password, if they're correct, then the application sets a JSON web token for you as a cookie called session, and then it redirects you to your account page. So we're going to take one of the requests that has the JSON web token in it and send it to repeater and work from there. All right, so let's put this side by side. Now, if we look at this request over here and hit send, notice that you render the My Account page for the regular user. And if we go to the JSON Web Token tab over here, you'll see that that regular user is in the subject attribute of the JSON Web Token. So as usual, the JSON Web Token has 3 components: the header, which contains the KID parameter. This indicates which key needs to be used to sign the JWT. And then you've got the algorithm, so we're using RSA. In the payload, it contains information about the privileges that the user has. And so we've got the issuer over here, which is Sportswigger, the expiry date of the JSON Web Token, and then the subject, which is our regular user. And then we have the signature. Now, again, we mentioned this in the first lab, but when it comes to JSON Web Tokens, there's quite a few attacks that you can try. In the previous lab, we checked if the JWT signature is verified. So we changed certain characters in the signature, and then we hit send, and we checked if it still accepted the token and allowed us to access the account. Now, we're going to assume that we already checked for this and it didn't work out. Now, the next thing that I usually check for when it comes to testing JSON Web Tokens is I check if the application accepts an unsigned JWT. Now, this attack is called the non-algorithm attack, and essentially the way it works is in the header over here, this specifies a public key algorithm, so RSA, that is being used. Now, in previous libraries for debugging purposes, the libraries used to have an option of including none as the algorithm so that the application does not have to verify the signature every time it receives a request. It was there only for debugging purposes and it was never intended for use in production. However, some developers did leave it configured in production, and so attackers exploited this vulnerability so that they could access any account on the system. And that's exactly what we're doing over here. So we changed the algorithm to none. if the library that the application uses supports this algorithm and the application is actually configured to accept this value in the algorithm field, then this attack should work. So the first step over here is to change it to none, and then the encoding will be done for us. Now, the next step is to remove the signature component. So we're looking for a dot, and here we go. Because like we said in the previous videos, this part signifies the header, and this part over here is the payload, and then after the dot, the last part is the signature. So now if we go back to JSON Web Token over here, you could see we've got the none algorithm in our header, and the signature right now is nothing because we've removed it. So let's try and access the admin panel. And I'm noticing I did forget one item over here. So if we go to the JSON Web Token, we've listed the algorithm as none. However, we're still trying to access the admin panel using a regular account. And so that's not going to work. We need the username of the administrator, which is just administrator. And this looks good. So now we've changed the algorithm to none. We've also changed the subject to administrator, and we removed the signature over here. Let's hit send and see if it works. And it does. Here we go. So this application is vulnerable to the none algorithm attack. Now the next step to complete the lab is to delete the Carlos user. So I'm going to copy this and put it in here. That's the path to delete the user. Hit send, and we get a 302 found. And you can see over here, it says, congratulations, you solved the lab. So we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. This script is going to look really similar to the previous script because we're essentially doing the same thing, except we're altering right now the header, and then we're also removing the signature of the token. So there's slight differences, but it's largely similar to the previous script in the last lab. So first we're going to import our module. So requests sys URL lib3. We're going to say from BS4, import beautiful soup. This will allow us to extract the CSRF token, the job module, and then base 64. Next, we're going to say URL lib3.disable warnings, URL lib3.exceptions, insecure request warning, so that it ignores the warnings. And then we're going to set our proxy settings so that all the requests that we perform in this script get sent to our burp proxy. So we're going to say HTTP, every HTTP request, send it to the proxy, which is configured on 127.0.0.1, port 8080. And then same goes for HTTPS requests. Send it to our proxy, which is configured at 127.0.0.1, port 8080. Okay, next we're going to call and define our main method. So if name is equal to main, then call the main method. And we'll define the main method right over here. We'll say if the length of the command line arguments is not equal to 2, so if the user enters incorrect number of command line arguments, then we're going to print the usage instructions and the example instructions so that the user can learn how to run the script correctly. So name of the script, and it takes in the URL, and we'll say sysargv 0, and then we'll also print an example. So we'll say example, name of the script, and the examples, let's just say www.example.com. which is just the site that I came up with. And again, it takes in the name of the script from the command line argument. Now, the user did run it incorrectly, and so we're just going to exit the script. All right, so you enter this clause if the user runs the script incorrectly. If the user does run the script correctly, we're going to create a variable called URL and set the variable to equal to the second command line argument. And then we're going to say regular username is equal to the username that we were given, and regular password is equal to the password that we were given. Now, you could have taken these as command line arguments, however, they're not going to change, and so I decided to just hard code them into the script. Of course, this is terrible secure coding practice and you should never do that. However, this is a test script, and so this is not really sensitive information. Now, next step is to create our sessions object. So request.session. And then we need to log in as the regular user. So the steps that we performed over here is we first logged in as the regular user, and then we extracted the JSON web token. We changed, if we look over here, we changed the header of the JSON web token by changing the algorithm to none, and we also changed the payload by changing the subscription to administrator. And then from there, we performed the request to delete the Carlos user. So we're going to need to perform all these requests in our script, and we'll start off with the login functionality. So we're going to create a function called login. It takes in the URL, the session object, the regular username, and the regular password. And we'll define this function right over here. We'll say def login URL takes in the session object, the username, and the password. And now if we go back to our proxy and we look at our login request over here, it was a post request to the /login endpoint, and it takes in a CSRF parameter, a username parameter, and a password parameter. I already know the username parameter and the password parameter, however, I need the CSRF parameter. So it's extracting it from the previous page, which is just the login page. If you look over here and look for CSRF, you could see this is the CSRF value. It extracts it from the response and it uses it in the post request. So in our script, the first thing that we're going to need to do is extract the CSRF token so that we could use it to log in as our regular user. So we'll say login URL is equal to URL plus the login path, which was just /login. Let's copy that, paste it in here, and then we're going to say CSRF token is equal to get CSRF token. So a function that we're going to create takes in the session object and the login URL. And then over here, we'll log in as the user. However, before we write the code that is responsible for logging in the user, we need to write our getCSRF token function and get the CSRF token. So we'll say get def get CSRF token, takes in the session object and the URL. To get the token, we need to perform a get request to the /login endpoint, and then from there, we need to look for, so let's make this bigger. We need to look for an input element that has a name that is equal to CSRF and then extract the string that is in the value attribute. And so to do that, we'll first perform the request. So s.get, it's a get request. It's to the login endpoint, which we included right over here. So we take in the login URL. We'll say verified to be equal to false because we don't want to verify TLS certificates, and proxies to be equal to proxies because we want our request to be sent to burp just in case we need to debug it. And then we're going to use the Beautiful Soup library to parse the response using HTML parser and extract the CSRF token. So we'll say soup.find. So look for an input element where the name of the element is CSRF. So this could be single quotes or double quotes. I used single quotes before, and so I'll just stay consistent. Okay, so we're looking for an input element that has name CSRF, and then we want the content of the value attribute. We save that in CSRF, and then we return CSRF. So over here, this will extract the CSRF token, and then it'll be saved in the variable called CSRF token. Now we're ready to log in as the user. So we're going to print logging in as the user, and then we'll add the username, and we'll add a few dots. Now to log in as the regular user, if we look at the request right over here, it's a post request. It takes in the CSRF token, which we just extracted, and then the username and the password. And so we do need to create another variable called login params, which are just the parameters that this request takes. And we'll say CSRF is one of the parameters, and that's saved in the CSRF token parameter. And then we've got username, which is saved in the username parameter that we pass to the function. And then we've got the password, which is saved in the password parameter that we pass in the function as well. All right, this looks good. Now the next step is to perform the request. So we'll say take in the login URL. The parameters is login params. We're going to set verify to be equal to false because we don't want to verify TLS certificates, and proxies to be equal to proxies because we want our request to be sent to burp. And then we're going to add another field over here, allow redirects, and set it to false. Because if you look over here in the post request, if it's successful, it'll redirect you to the My Account page. So it's a 302 found. Now, I want to extract the JSON web token from the redirect before you actually get redirected. And so with requests, it'll automatically redirect. However, if you set it to false, it won't redirect, and so you'll be able to extract the token. So we're going to say if r.statuscode, so if the status code of the response is equal to 302, so it's a redirect, then print login is successful. And we're going to extract the JSON web token, so r.cookies. And we want the session cookie. And then we'll return the JSON web token. So we set the session cookie because you could see over here, the JSON web token is saved in a cookie called session. Okay, now if the status code is not 302, that means that the login was unsuccessful. So we'll say login not successful, and we'll just exit the program because this is an authenticated exploit, and so you do need credentials in order to perform this exploit. All right, this looks good. Now, if we go back over here, the way we set this up is that the login functionality returns the JSON web token. And so what I'm going to do over here is add a parameter, regular user jot, and set the return value over here to this parameter over here. So that's going to be the JSON web token of the regular user. And then I'll say if regular user jot is not empty, so if the exploit worked, then I want to perform the attack. I won't perform the attack yet because I want to run my exploit to see if there's any errors. And so I'm just going to save over here, go to terminal, new terminal, and run it. And then we'll write the code for the exploit. So Python 3 jot attack lab 02.py, and let's see if this timed out. And it did. So let's access the lab again. Now, if this is written correctly, all it should do is extract the CSRF token and then log in as the regular user account. Okay, let's copy this, paste it in here, remove the trailing slash, hit enter, and perfect. It says login is successful, and so it was able to log in. Now that we don't have any errors, we could continue with the rest of our script. So now that login is successful, I'm going to create a new function called JWT. So JWT signature, verification, attack. It takes in the URL and the regular user JSON web token that we just extracted. Now, this function is responsible for performing my attack, and so I'll add it right over here. So let's say def JWT signature verification attacks. It takes the URL and the token. And let's put this up. First thing we need to do is extract the content of the JWT. So let's say extract content of JWT. So if we go back to burp over here and we go to repeater, in the JSON web token, you've got a header, a payload, and a signature. And so we're going to extract the header, the payload, and the signature of the regular user's token. And we'll do that by just splitting the regular user's token on the dot or the full stop character, because again, with JSON web tokens, these are separated by a dot. So over here is the header, and then this over here is the payload, and then the last value is the signature, which we removed. Okay, after you split it, you need to decode it, and this time around for this lab we need to change content in the header, and we also need to change content in the payload. And so we need to decode, or let's say modified header. We'll use base64.url safe b64 decode, and we're decoding the header. Now, if you run this and it's the incorrect padding, you're going to get an incorrect padding error. And so we're going to add a piece of code that pads it with a number of characters. And it doesn't really matter if it's too much padding, because the B64 decode functionality will remove any unnecessary padding. So if you have too little padding, you'll get an error. However, if you have too much padding, that's okay, because the function will take care of the unnecessary padding and remove it. And so we do that with this piece of code. This looks good. We're going to copy this and say modified payload, because we're doing the same thing except for the payload. So we'll say payload right over here. Okay, this looks good. Now the next step is actually to modify the header and modify the payload. And so I actually named these incorrectly. Because it's confusing, we'll just name them decoded header and decoded payload, because we're not actually modifying them, we're decoding them. Now to modify it, let's do that first for the header. So we'll say modifying the header. So to modify it, we'll say modified header is equal to decoded header. So the value that we just decoded, and then we're going to replace the RS-256 algorithm, so the RSA algorithm, with the none algorithm. And so if we look over here, it's exactly what we did with the JWT editor extension. we replace the RSA algorithm with the none algorithm. And we are dealing with bytes, so we do have to add B. So that's for modifying the header. Now let's modify the payload. So let's say modifying the payload. This is decoded, now modified payload, and this is incorrect. Here we go. Let's copy this. Say modified payload. And in this case, for the payload, we're just replacing our regular username with the administrator username. So we'll do that right over here. And that's replaced by administrator. Okay, this looks good. So now we've made all the modifications that we needed. So what's left is to re-encode the header and the payload, assemble our JSON web token, and then use the new JSON web token in order to perform our attack. So let's say create new administrator token. So first thing we're gonna need to do is encode the header and encode the payload. And so we'll say base64.url safe, b64 encode, and we're taking our modified payload or modified header. So we'll do the header first, modified header. And we're correctly encoding it. So this is exactly what this tool is doing over here for you, but it's doing it all in the background. It first decodes the JSON web token for you, and then once you perform the changes over here, it's actually encoding it on the fly, which is exactly what we're doing here. So we need to do that for both the header and for the payload. Now we don't care about the signature because that's going to be left empty. So let's say payload. And this looks good. Now we just assemble it together. So modified token is equal to, we'll use f strings over here to assemble it together. So we'll say first the modified header, and then we'll add a dot, and then we'll add the modified payload, and then we'll add another dot, and we won't add anything because we don't want to add the signature. Okay, and then I'm going to print that it generated the administrator token. And I'm actually going to print the modified token just to confirm that everything is running correctly before we continue with our script. So we'll go terminal, new terminal. Let's run it one more time. And that closed off for some reason. New terminal. And let's go to this one. So let's clear. And I think this might have timed out. Oh, it did not. Perfect. So do we have that? We do. All right, let's hit enter. And we do have invalid syntax. So if we go over here, I believe this has to be in double quotes, if I'm not wrong. So let's save it, clear again, and run it. And this is why it's important to actually run your script. So over here, right away, I can tell something is wrong because it did not encode my JSON web token, and I don't know why. So I am using the encode function. However, if you look over here, I'm using the decoded one. So I'm using this one over here, modified header. So if you look over here, it's this one, which is decoded. I need to use modified header encoded. So let's do that. And then also for the modified payload encoded, because that's the encoded version. Let's save it, clear, and run it again. And here we go. Perfect. So this looks good. So we've got our encoded token. So we could remove this right now and write the remaining exploit. So we've successfully logged in as the regular user. We've successfully changed the token so that it's an administrator token. Now all we need to do is go to repeater and perform the request that deletes the Carlos user. And so let's put that in here and say use new token to delete user. And then we'll say print attempting to delete the user, Carlos. Now, to delete the user, the first thing we're going to need to do is place our modified JSON Web Token in a cookie called session. And so we're going to create a variable. Let's put this a little bit up. We're going to create a variable called cookies. And that's an array of the cookies. In this case, we just need one called session. And we're going to set it to our modified token. Now, all we need to do is perform this GET request to this path right over here. So we're going to say r is equal to request.get. It takes in the delete Carlos path, which we have not set yet. So let's say delete Carlos URL is equal to the URL of the application plus the path to delete the Carlos user, which is this one over here. Let's copy it. Now we're performing a GET request to the delete Carlos URL. We're setting cookies to be equal to cookies and verify to be equal to false, and then proxies to be equal to proxies. Okay, this looks good. Now the next step is to see if you'll receive the user is deleted successfully message. So we're going to say res is equal to r.text. That's the response from the GET request. And we'll say if user deleted successfully is in the response, so is in res, then print successfully deleted the Carlos user. Otherwise, print that the attack was not successful. Okay, this looks good. Okay, hopefully we do not have any errors. Now, when we run the script, all of our requests should show in the proxy, and so we should see them as the script runs. Let's save it, go to terminal, new terminal, clear, and run the script again. And you can see over here, all the requests are being performed. However, our attack was unsuccessful, and that's probably because we already deleted the Carlos user. So if we go over here and then go to username Carlos, oh, it says that it's unauthorized, which means that there is something wrong with my JSON Web Token. So let's send this to repeater, and this is why I like to send all the requests to repeater so that I could actually view them. So over here, we're not even getting the JSON editor tab because it's not viewing this as a JSON Web Token. So we need to go back and see if we performed any mistakes in our encoding or our decoding. Okay, so right away, this is for the payload, but this should be for the header, not the payload. I wonder if that's a mistake. I think it might be because you could see that we've got an equal sign over here. So let's save it and rerun it again. If we still get an error, that means it's something else. So hit enter. And we still get attack unsuccessful. And if we go over here, it's also unauthorized and it's not viewing it as a JSON Web Token. So something is definitely wrong. This looks fine, so maybe it's our encoding. And I'm actually going to make this bigger because it's hard to read. Okay, so I'm not exactly sure what the issue is. So what I'm going to do is I'm actually going to print the modified payload to see exactly what's going on. So the modified payload is, ooh, okay. So that is way incorrect. So the payload should have the subject in it, not the KID and the algorithm. So we definitely did something wrong over here. So we've got header, that's correct, payload and signature. And then in header over here, we're changing the header. And here we go. I see what the issue is. So over here, this should be decoded payload because all it's doing is essentially trying to change the header again. However, it doesn't find this username, and so it just keeps it as what we originally changed it. So I think this should resolve the issue. So I'm going to clear. Let's make this smaller again so that we could see verb. This is fine. And hit enter. And we could see our request being performed. And it still says attack is unsuccessful, but I could see that it says congratulations, you solved the lab, which is weird. So if we look over here and we look for users deleted successfully, the message is there. However, if we go over here, oh, and I have a mistake in my string over here. So I said user delete successfully, so I couldn't find it. However, it should have said user deleted successfully. So we're going to try this one more time, except we're going to try and delete the other user because we can't delete the Carlos user twice. So I'm going to change this up. I won't change the name because after the video, I'm going to change it again to Carlos in case you're running this script. However, this should work. So let's say save, clear. I don't think there's anything else that we need to change. The messages are going to still say Carlos user, however, it's going to delete the other user. So hit enter. Here we go. It says successfully deleted the user. We're deleting the other username over here, but if you go over here and say user deleted successfully, you could see it. And under user, there's no longer any users because we deleted both users of the system. So I'll change this back to Carlos. And I'll add a link to the script in the description of the video in case you want to run it or in case you're running into any issues with your script and you want to compare it with my script. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at another case of a JWT attack.